Hello friends, welcome you to my channel. So in this video we are going to see control sequence for an instruction where one of the operand is specified in your direct mode. Hope you remember what is direct mode. Direct mode, another name is absolute mode. In case of direct mode, data will be there in memory and the address of the data will be there as part of the instruction, right? So here my first assumption is that my instruction consists of one word. That means inside one word only, I will get the address of the operand also. Once instruction is fetched, I will get the address also. From that address, I'll bring the data and I'll do the operation as per the opcode of the instruction. So this is how we are going to proceed. So see here, my instruction example is move 300, R1. What this instruction is doing? Content of memory location 300 is transferred to register R1. Please do understand, whenever I am saying transfer to R1, the original content from memory location 300 will not be destroyed. So now here the point is not that. We are going to start with the control sequence. And see, to do this control signal, we will be using this single bus organization. So very first, we need to fetch the instruction from memory. So to fetch the instruction from memory, we need to give the address to MAR because here only the connection with the memory chip is there. So MAR, to this MAR will give this address and then we will give the signal to perform the read operation, and then after some waiting data will come in MDR. This is how the protocol is there. But now see, where is the address of your instruction? Obvious is program counter. So from program counter we need to bring the address into MAR. There is no direct connection. So what I will do? PC out. That means content will be placed on the bus, and then from the bus it will be given to MAR. So what I'll write? PC out, MAR in. That means address is given. Now after giving the address, we need to tell the direction of communication. Here it is read. Read means we are getting something from memory. So read. That we have done. Now see, we have to wait for some time till the data comes from memory. So during that time, we will try to do whatever is possible to do without that instruction is brought from the memory. So in the meantime, we'll increment the PC because the original address of the instruction is already given in MAR. So now we can proceed with incrementing the PC. So to increment the PC, here my assumption is my instruction length is 4 bytes, machine is byte addressable, right? So and the word length is also 4 bytes. So select 4 because who can do the increment? Increment means nothing but a plus operation. Who will do that? ALU can do it, right? So when ALU will do it, it requires both the inputs. Right now on the bus, PC content is there. That means it is available on the B input. Now next input is 4. So that I will bring through the mask. By how? Means how we are going to get this 4 into this A input by writing this, by choosing this select line. So select 4 will choose this constant 4 for the A input of the ALU. So add then Z in. So see, already PC out. That means it is on the B input. Now see, here we have done select 4. That means this value will also come to A input. Now we can give the signal add. Result will be taken in Z in register. This part is clear. The next is from the Z register, the result has to be transferred to PC because it is PC equal to PC plus 4. So Z out, which register we need to take? PC. So PC in and then Y in. So this much is done. After that, we have to wait for the instruction to come from memory. So for that, we will give the signal WMFC. And when we will come out of this signal, when memory will give us MFC, that is memory function complete. Once we'll come out of this, what does it mean? That by the cycle we receive MFC, in that clock cycle's ending part only, data will be loaded from the bus into MDR register from this side, from memory side. So now the whatever we want to read from memory has come in MDR. Now from MDR, where I need to take it? To IR because I am doing the instruction fetch. So MDR out, IR in. From one register to another register, we are bringing the content. This part is done. Now, once the instruction is in IR, we will understand that our operand is in memory whose address is there in the address field of the instruction or offset field of the instruction. So what I will do, address field of IR out. Please do understand here my assumption is instruction length is one word. That means within that one word, the address will also come along with your opcode and other information. So address field of IR out, because in one part of your IR only the address will be there, and then that address will be given to MAR because I need to get the data from memory, and then the read signal, right? Then here we can't do anything more because nothing more is there to do, and then we have to wait till the data comes, and then data will come in MDR. From MDR it will be given to R1. So this much we need to do for this instruction. Everything is done, so it is end. That means end of this particular instruction. Hope this part is clear. Do understand here the control sequence is written with the assumption that my instruction length is your one word and the word length is your 4 bytes. Due to that, machine is byte addressable. Due to that, we are incrementing PC by 4, and by that we are reaching to the next instruction, and within the current instruction we will get the address field of the instruction where my EA of the operand will be there. So this much is there for this one word instruction control sequence. And see, whenever we are writing it, we are using this single bus organization. Next, same addressing mode we will see, but our assumption will be changed. Hope you remember direct mode, another name is absolute mode, right? So here it is said, write the sequence of control steps required for the given bus structure. That means for this diagram, for the following instruction. What this instruction is telling you to do, add the contents of memory location num to register R1. That means num will be part of instruction, but it is not data, it is your memory location. In this memory location, something is there that you need to add to register R1. So you need to bring it from memory, right? That means the data you need to bring from memory. Where is the address? In this num. And where is this num? Now it will be changed. See the assumption. Assume that each instruction consists of two words. The first word specifies the operation, addressing mode and all, and the second word contains the number num. That means now my assumption is that my instruction length is two words, right? It is not assumption, it is given that the instruction consists of two words. If the instruction consists of two words, so if the instruction starts at 1000, where is the next instruction? At 1008. 1004 will hold this num. First part will hold that opcode, addressing mode and other information, right? So PC will be having 1000, and after this instruction, PC should have the value 1008. So that part we need to take care. And to get the data from memory, we need to read the contents of memory location 1004. This time we have to do that because num will not come as part of your IR. It will be in the next word following that opcode part and the first part of your instruction. So see, next we'll see how to do this. So see, first part, see instruction will look like same only. Do remember we are doing two word instruction. So add num comma R1. So first we need to get the first part of the instruction. So who is pointing to it? PC. So PC out, MAR in, read, select for, add, Z in. Explanation is similar to my previous explanation. So again, I'm not repeating. Then Z out, PC in, Y in, WMFC. This part then MDR out, IR in. That means by now from my instruction, content of 1000 is brought into IR, right? Once it is brought into IR, it is decoded. We got to know that our instruction length is 2 bytes and the next word, sorry, my instruction length is 2 words and the next word contains the address of the operand. So now we need to proceed with reading the contents of the next word. Next word is located at 1004. Then we will read that. By reading that, what we will get? This num. And after getting that num, from that address, we need to get the data. That data need to be added with R1. And result will be also stored in R1. And when we will be fetching this num from this 1004, that time PC will be incremented to 1008. So here our next instruction will be there. next instruction in sequence will be at 1008, right? Why it is so? Because my instruction, total instruction length is 2 words. So this part is done. Now see, again I need to perform a memory operation. So that time what I will get? This num we will get. Who is pointing to it right now? PC is pointing to it. That address is also there in Y register. But from Y register, I can't put it directly on the bus. So better I am keeping PC out, MAR in, and then read signal. Address is given to MAR, then the read signal. So once I have told memory to read, and then I have to this one. I can increment the PC to next instruction. So select for add Z in, Z out, PC in, Y in, WMFC. This part is similar to my this one because at 1004 my address part was there. After that only next instruction will be there. So 1004 plus 4 again I am doing to go to the next instruction, right? So this is how we are doing it. Why I am doing it like this? Because of this diagram, because of this particular architecture, right? If the architecture changes, my control signals will also change, right? So with this underlying diagram in our mind, we are writing these control signals. So done. And then after this particular memory operation is over, means MFC is received from memory, then something will come in MDR. What is that something? This num, right? Right now num was not there part of IR. It is there in the next word of your instruction. So MDR out, MAR in, because here I have got one address only. From that address, we need to get the data. So to get the data, what is the protocol? Give the address to MAR. So MDR out, MAR in, then read. And then what I can do, this R1 content I can place in the Y register. So after that, nothing is there to do till the data comes. So WMFC. And then once I receive MFC, I'll come to the next step. And where is the data? In MDR. So MDR out means it is there on the bus. That means on the B input. MDR out. Already Y register is containing the first R1 content. So select Y. So this will bring this one here. Done. So both the inputs are there. Now you give add signal to the ALU. Done. And once the addition is operation done, the Z register will contain the result. So Z in. In the same clock cycle, I cannot put the result on the bus. So I will keep it in the Z register. So now in the next clock cycle only, Z out we will do. So that will have the result of my addition process. And where I need to take it to its destination operand. Here destination happens to be R1. So in R1, we are giving the result from Z register. And then these instructions, for this instruction, whatever is required to do, everything is performed. So this instruction is over. So it is end. So that we can prepare ourselves for the next instruction in sequence. For that instructions execution, we can prepare ourselves. So this is end, right? So this much is there for your absolute mode, addressing mode operand. But do remember, first example I have done with the assumption that my instruction consists of one word. And in the second one, we have taken two-word instruction. That time, two times I have read from the memory. Then only my fetch and decode cycle will be over. And then next cycle will start my execution. And there we'll get the data from memory and will perform the operation and will store and has stored the result in register R1. So this much is there in this video. Hope you are getting from my explanations. And if you are liking my explanation, then please like my videos and subscribe to my channel. Thank you.